The question is belongs to the mathematical induction. And the question task is use the mathematical induction to prove the following formula for every positive integer. The question is in front of you. As we have already learned the rules, we need to prove for n is equal to 1. This is the last term, Tn, and this is a sum value. That should be equal. Like 3 into 1 minus 2, 1 into 3 into 1 minus 1 upon 2. 3 minus 2, 3 minus 1 upon 2 into 1. It will become 3 minus 1 is 2, 2 upon 2 is 1, 3 minus 2 is 1. It means that the left hand side and the right hand side value is same. It means that it is valid for n is equal to 1. Again, students, I'm telling you, it is not necessary every time it will come 1 is equal to 1. Maybe it can be 5 is equal to 5, 3 is equal to 3, 2 is equal to 2. It means that when left and right value will be same, it is valid for n is equal to 1. Now need to go on the for n is equal to k. What we will do, we will just write it down like 1 plus 4, the statement up till 3, the n will be replaced by k minus 2 is equal to k, 3k minus 1 upon 2. This is for a static equation. What is the trick? What is the logic? The nth term. The nth term is Tn, the last term or the general term. What is the last and the general term? I'm indicating you. This is called the last term or the nth term, or you can say that the formula. We will take this one. This is the trick. We will just write it down and n will be replaced by k plus 1. Rewriting it, k plus 1 minus 2. It means that it will become 3k into 3. 3k plus 3 ones are 3 minus 2. 3 minus 2 is positive 1. It means that it is the term that will be added on the both sides in the static equation. Now we are proving for n is equal to k plus 1. 1 plus 4 till 3k minus 2 is already in the static equation. Whatever we are adding with a different color, I am writing it like 3k plus 1. 3k plus 1. Again, is equal to 3k into 3k minus 1, the wholly divided by 2, and 3k plus 1 will be added on both sides. Now we need to work for this statement. It is understood that it should be the last term will be equal to this sum. Then how we will prove it? We will just write it down. 3k square minus k upon 2, 3k plus 1. 3k plus 1. We will just take the LCM. It will become 3k square minus k, 3 2s are 6k, 2 1s are 2 upon 2. We will simplify it. It will become positive 5k. 3k square plus positive 5k plus 2 upon 2. Now apply the quadratic formula. You can apply the quadratic formula. You can do the central common factor. 3 2s are 6. It means that when we'll make the factor, it will become 3 plus 2 or 2 plus 3. Both are correct. 3k square, 3k plus 2k plus 2 upon 2. 3k is the common one above in the first two terms. And 2 is common in the next two terms. Now 3k it's become k plus 1. 2 it will become k plus 1. If you have done right, definitely the bracket will be same like this. It's 3k plus 2 upon 2. Now we need to check either it has become in the format of the sum. Like what is the sum? It is here. This one. This one. Just right in front of it and just check. Like what we need to prove? It will be like n into 3n minus 1 upon 2. The n will be replaced by k plus 1. Yes, it is here. N will have k plus 1. Yes, it is here. 2, it will have. Now, we need to check the 3 and will be replaced by k plus 1 minus 1. Then it is giving the same product that is here or the different one. For example, this 3n, the n will be replaced by k plus 1 minus 1. 3k plus 3 minus 1, 3k plus 2, it's coming. Yes, it means that yes, it is valid for n is equal to k plus 1. Proved. Answer.